Hello, everyone, and welcome to Precalculus. This is section 7.5, Systems of Inequalities. You may recall that a solution to a system of equations is the point or points common to every equation in the system. So if your system included a parabola and a line, the solution to that system would be those 2 points. But in a system of inequalities, the solution will not just be a point, but a vast shaded region. So in order to sketch the graph of an inequality, you're going to replace the inequality symbol with an equal sign, and then just sketch the graph of the equation. You can use a dashed line for greater than or less than, and a solid line for greater than or equal to or less than or equal to. And then you're just going to shade the appropriate region by testing a point. I use 0, 0 whenever possible, but sometimes that's actually on the line or on the curve, and then you can't use it, but you can use a different one. So let's jump right in and do number 1. X minus y is less than 2. So do yourself a favor and just change this to x minus y is equal to 2. And you can worry about the inequality at the end. So I would move the 2 to the left and the y to the right. And this is just a line. I know one point on the line is at x is equal to 0, negative 2. And I know the slope of the line is 1, so I can go up 1 over 1. Now, because this is a less than symbol and not less than or equal to, I do want to make it dashed and not solid. So it would look like that. And then my next one is going to be a horizontal line. Y is equal to 3. So again, you can just pretend that it's y is equal to 3. I'll make it in a different color. Y is equal to 3. And it's solid. And the last one is x is equal to negative 2, which is a vertical line. And it would look like that. So now you need the shaded regions. So for the first one, I need to know if I want to shade above the black line or below the black line. And I just pick 0, 0. 0 minus 0 is less than 2. That's true. 0 minus 0 is less than 2. So I want this to be one of the solutions. Now, to keep my graph from getting cluttered, I'm just going to make a little note that I would have shaded on this side of the line. And if this was my only problem, I would actually shade that side. But since I just want to shade the area that all 3 have in common, I'm just going to do that. For the next one, I plug in a 0 into here. Is 0, I can't plug in a 0 for x, so just for y. Is 0 less than or equal to 3? Yes. So again, determining whether or not I want to shade above the red line or below the red line, 0, 0 works. So I want to shade 0, 0, so I would be shading below the red line. And then finally, on the blue one, is 0 greater than negative 2? It is greater than negative 2. So I'm going to want to shade the 0, 0, which would put me on this side of the line. What region encompasses all 3 of those shaded regions? This region right here. Now, some of you are going to always choose that region because you just don't understand that it could be anywhere else. But sometimes it's going to be this region over here or this region over here. And you can't assume it's just always the region right in the middle like that. So we'll do lots of different examples today, but we'll start with that one. All right, number 2. This is a parabola. Remember, I'm going to ignore the inequality and just change it to x squared minus 1 is equal to y. Hopefully, you recognizing at this point that it's just a parabola that's been moved down 1 and not left or right. And the points that you should have memorized are 0, 0, 1, 1, 2, 4. So I move down 1, that's my new origin. And then from there, 0, 0, 1, 1, 2, 4. And I'm going to reflect that over its own line of symmetry, which happens to be the y-axis. I can make a solid line, since it is less than or equal to. And now I have to decide the shading. I go back to my inequality and I plug 0 in because I want to know, should I shade 0, 0 or shouldn't I? So 0 squared minus 0 is less than 1. That's true. So I do want to shade inside the parabola. But I'm not actually going to do it because I want to see what the other section needs. So this one is y is, again, I'm not going to use the inequality symbol. I'm just going to say y is equal to x plus 1, which is a line whose y-intercept is at 1, and then it has a slope of 1. And if we were just doing points of intersection, you would have found them, but we're doing entire regions. And now I'm going to plug in my 0, 0. Is 0, 0 less than 1? It is. So I do want to shade the 0, 0, so I'm going to go underneath. And this is another one where the answer is that region right there. Cruising along, let's do number 3. Number 3 is 2 lines. The first one is y is equal to negative x plus 3, which is up 3, and then it has a negative slope. Now, because this is just a greater than sign and not greater than or equal to, I need to make a dashed line. So let me go ahead and make that dashed. And then my other line is y is less than negative x minus 1. So it also has the same slope, but a different y-intercept, and it is also dashed. So on the green one, if I plug in a 0, 0, is 0 plus 0 greater than 3? It is not. So I don't want to shade 0, 0, so I would shade above the line to avoid shading 0, 0, which is not a solution. And then for the blue one, 0 plus 0 is less than negative 1. It is not. So again, I don't want to shade 0, 0, so I would shade on this side. So the question is, what is the intersection of these two shaded regions? There is no intersection. So there is no solution. Okay, so don't shade anything. Sometimes people then will go back and they'll actually shade this region and they'll shade this region, but that's not the answer. You only want the region that they have in common. So I've been shading the answer. And this one, don't shade anything because there's nothing that they have in common. All right, number 4. I have a parabola and a line. So my parabola hasn't been moved left, right, up, or down. I can just do 0, 0, 1, 1, 2, 4 and reflect it to the other side. I don't have to make it dashed because it's greater than or equal to. So on this one, I can't plug in 0, 0. So you can plug in any point you want to. So let's try plugging in that point right there, 0, 2. So I'm going to plug in 0, 2. 2 is the y. Is 2 greater than 0? It is. So I do want to shade 0, 2, which means I want to shade inside my parabola. And then this is the line, y is equal to x plus 2, which is a line that's been moved up 2 and has a slope of 1. It is not greater than or equal to, it's just greater than. So I do need to make a dashed line. So it would look like that. And I can plug in 0, 0 because it doesn't actually go through 0, 0. Make sure you plug it into the inequality. Is 0 greater than 0 plus 2? It is not. So you don't want to graph 0, 0, which means I would want to graph above the line. So this is our first example where it's not that basic region that sometimes people just choose without really thinking that carefully about it. But it's going to be this region right here. Any point in that region should work in both equations. So I'll just pick this point right here as a check. This is a great thing you can do if you have extra time. 1, 5. 1, 5 should work in both. So is 5 greater than 1 squared? It is. Is 5 greater than 1 plus 2? It is. So I know with absolute confidence that I've shaded the correct region. Number 5, practicing another couple graphs. Hopefully you recognize this one as a circle with a radius equal to 5. This is the radius squared. So I'm going to go ahead and draw it. I personally am really bad at circles, so I'm just going to draw a quarter circle at a time. And somehow that makes it just a little bit less egg-shaped for me. And then natural log of x, you need to know, whenever you think natural log, you need to know that it has an, unless it's been moved left or right, which this hasn't, it has an asymptote there, and it goes through the point 1. So I'm going to do that. I'm going to give it its asymptote, and then I'm going to draw its graph. I don't really need any other good points. This is good enough for me. So y is greater than the natural log of x. So now the question is, how do you test a point if you can't do 0? There's an asymptote there, so you can't do the natural log of 0, and you can't pick 1. So why don't we just pick this point right there? Why don't we pick 2, 0? So is 0 greater than the natural log of 2? It is not. And you could check natural log of 2 on your calculator, but if you're thinking, I don't know how to do that, then you could e both sides. E to the 0 is greater than e to the natural log of 2. Anything to the 0 power is 1. Is 1 greater than 2? But maybe you just know that natural log of 2 is going to come out to be an actual number. So I don't want to shade that point, which means I want to shade on the other side. But this one is still a little bit tricky. Well, let me actually go back and do the circle first. Is 0 plus 0 less than 25? It is, so I want to shade inside my circle because I do want to shade 0, 0. But the actual answer to this one is going to be just this region in here, because you can't go past 0. There is no natural log of a negative number. The graph actually ends there. So a little bit of extra thinking as you're getting to the end of the year in Precalculus, so we keep putting together all the different concepts that we've learned. Okay, last one, but it is a hard one. It's got a lot of lines on it. We're just going to take them one at a time. So starting with the first one here, I'm going to use the intercept method. If x is 0, then y would be 2. But if y was 0, kind of cross that all out, then x would be 3. And I can just plot those 2 points, and that'll tell me my slope. Now I can see it's down 2 over 3, and I can keep using that to get all the way across my graph. There's nothing wrong with setting it equal to y, but I'm trying to give you some more options. But if you did that, it's negative 2/3 x plus 2. You're always welcome to do that. I do want to check 0, 0 real quick to see which side to shade. And since 0 plus 0 is not greater than 6, I don't want to shade 0, 0. So I'm going to go to the other side here. Next one. So this one, my intercept method isn't that great, because if x is 0, y is negative 15, and I can't graph that. I can say that if y is 0, x is 5, so that's a nice point for me. And on this one, it's really not so hard to move the y to the other side and the 15 to this side, and then I can see that the slope is 3, so up 3 over 1. And sure enough, I can picture that. If I did keep going down, I can see how I would hit negative 15. So I feel confident that my line is correct. I check my 0, 0. 0, 3 times 0, minus 0 is less than 15. So I'm going to want to shade on this side of this line because I want to make sure 0, 0 gets shaded. Next one. This one's another good choice for my intercept method. If x is 0, y is 4. And if y is 0, x is negative 4. So let's go ahead and plot those. And then negative 4, 0. And it has a slope of 1 I can see. So everything's solid lines, which is nice. I'm going to test my 0, 0. 0 plus 0 is less than 4, so I want 0, 0 to end up being shaded, so I go under this line. If you did not like my intercept method, this would have been, this is a nice easy one to just move the x to the other side. Lots of choices. Okay, I do want to focus on this last one here because the intercept method won't work because it's not evenly divisible. So I know that you're going to want to move the 2x over to the other side, and then you're going to want to divide by 5. My big advice to you is before you do this next step, there's nothing wrong with this next step, except that I don't want you to try to plot 27/5, which is 5 2/5. You can plot it if you want to, but I don't want you to try and start at 5 2/5 and go down to and over 5. It just simply won't be a very nice graph. It won't be exact. So find one good point. And the way you can do that is just by making a table and picking an x that when you multiply by -2 and add 27, you can divide by 5 easily. So we've already decided that 0 won't give you a nice number. But look at this. The very first one I think of, 1. 1 times -2 is -2, plus 27 is 25, divided by 5 is 5. So it's not usually that hard to find a good point. So 1, 5. And then from there, I'm going to go down 2 and over 1, 2, 3, 4, 5. Down 2 and over 5. And it does go through that y-intercept that I anticipated, but with a lot more accuracy. 0 plus 0 is less than 27, so I do want to shade underneath here. And if I look at all the shaded regions in combination, it makes this very tidy center section right here. And that is the actual answer to the question. When it says find the system, or when it says find the solution to the system of inequalities, all the points in here are solutions. Any point in there that you tried. So if you picked this one, 3, 2, 3, 2, because it's in this region, should work in all 4 of these graphs. All right, that is it for section 7.6, 7.5. Have a great day.